Hello everyone, I'm Eric Kochi, and today we'll present a project that brings together artificial intelligence and Nomad through MCP server developed in Go. So the goal is to create an infrastructure that allows AI system to interact with external tool in a standardized and secure way. In particular, I will show you how this approach can help automate real-world tasks inside a Nomad cluster, making infrastructure more dynamic and reactive. So we can start just a few words about me. I'm currently a master's student in computer science at the University of Bologna. I'm passionate about DevOps, automation, and cloud technology. And right now I'm in Nice, in France, completing my master thesis, which I will finish it in October. Alongside my studies, I've also worked on several open source projects, especially in the field of infrastructure, orchestration, and some AI tools. You can find me on LinkedIn or GitHub if you would like to check out more of my work or get in touch. So let's begin by briefly defining what an LLM is. So a large language model like ChatGPT, Cloud, or Gemini is trained on a massive amount of text data and is capable of generating natural language and answering complex questions. This model have transformed many fields from content generation to code assistant, but they also come with important limitations. For example, they have a limited memory, so they can forget information provided early in a long conversation. They can generate hallucination, meaning they may invent data or cite non-existing sources. Their knowledge is static, so it's limited to what they were trained on, so they don't know anything that happened after their last training. And they are also prone to bias and reasoning limitation. Because of this, using them in a critical or production environment can still be risky unless we had more control and awareness to their behavior. This is exactly where AI agent come into play. Unlike a simple chatbot, an AI agent can access private content like files, database, personal note. It can also fetch real-time data like stock price, the current weather, or breaking news. And last but not least important, it can perform actual operations such as calling an API, or modifying configuration, or comparing dataset, for example. To enable all this through, we need a standardized, safe, and modular way for AIs to interface with the outside world. That's where MCP comes in. MCP stands for Model Context Protocol. It's a standard proposed by Anthropic in November 2024, and it works just like a USB port, connecting LLMs to external software in a simple and pluggable way in this case. This means we can extend our LLM with a new capability without modifying them, simply by using a shared interface that both sides understand. So, before diving into how the MCP primitive works, which are prompts, resources, and tools, let's take a quick look at the overall architecture of the protocol. And actually, it's pretty simple. We have the hosts, which are program or AIs that want to access the data, such as Cloud Desktop or even IDLE like Visual Studio Code, Cursor, ZED, assuming they support MCP. Then we have the clients, which create a one-to-one connection with the server. And finally, we have the server, like the one I've developed, which expose and execute external functionality according to the MCP standard. In my case, the server is directly integrated with the Nomad API, and it also provides a web interface to interact with the cluster. Later on, I will show you a live demo so you can see this all in action. But now let's look at all the three main primitives of the protocol. In particular, we start with the prompt. Prompts are simple instructions or templates that guide the LLM on how to perform a task. So In the example show, we define how the model should interact with the user. So in this case, we are saying the model should say in a friendly tone by greeting them. But we could just use another prompt to instruct the model to give more quantities or more detailed answer, depending on the use case. So yes, next we have the resources. That the resources allow to load mod documents such as project documentation, which the model can consult when needed. In this example, we uploaded a basic file, but we could just easily load a CSV file, a full directory, or a database dump. The model can then use the data when we ask it to perform tasks or answer questions related to the content. This expands the model context without retraining it, just by injecting relevant external information. And finally, last but not least important, we have the tools. The tools are actual functions that the model can invoke to interact with the external system. For instance, it could launch a nomad job, retrieve the status of an allocation, or delete a variable from the system. These tools are modular and configurable, which mean they can easily adapt to different domains, from DevOps to security or to data science. In the code, you will see we first define input validation. We specify which fields are required, their type, and provide a short description. Then we move on the implementation, which in this case handle the 4 operations of a simple calculator. So we have the addition, the subtraction, the multiplication, and the division. And all of this is returned to the LLM, which processes the result and give us a human readable output. The great thing is that the model doesn't just call the function, it explains the result, interprets the data, and can even suggest follow-up more action. So now that we have seen all the 3 primitives, now let's look at the basic MCP configuration, which is just a JSON file, and in it we define the server name, the command the model should use to run the server, its argument, and any environment variable. In my server, we have 2 key environment variables: the Bootstrap ACL token, used if the Nomad have the ACL enabled, and the Nomad client URL, so the model can communicate using the Nomad API. This setup makes the server portable and easy to deploy in different environments. But now, let's see a real-world examples of how we can use the MCP server to automate practical tasks. In this demo, we'll be interacting with a Nomad cluster directly using a natural language. So we begin by sending a simple prompt asking to initialize the ACL token and show it to us. Then we deploy a web application, specifically an Nginx server with 2 instances. We check the application log, we wait for the deployment, we scale it to 3 instances, and finally we ask to a link to verify that everything is working. So let's dive to the demo. Okay, so as I said, we initialize the CL, create the deploy of the web application, we check the log, we scale the application, and finally we have the link of the Nginx app. So let's start. So we stop the ACL token, we allow for this chat the execution of the tools. Okay, now we have the secret ID, which we are copying it in the clipboard to use it later in the web interface of Nomad. We are creating a deploy. We are deploying the application with 2 instances using Nginx, and after we are checking the log as we said in the prompt, and we are seeing if all is deployed fine. So now the job is in pending stage, so the model understands that should wait a little bit more. Okay, which we also checked if the node is available, so it's doing some troubleshooting way to understand why it's not deploying the instance. Okay, we are checking again the deployment, which now is running. Okay, we are checking now the status to check if all is working good, particularly the allocation. And in this case, yeah, you see an issue about the deployment because there is a constraint about that require console 1.8. So he updated the job specification without this constraint, and now we try to deploy the application, and this time works. So we have two allocation running. Perfect. We check the log if all is fine. Now we scale the application to 3 instances, because actually we have 2 instances, so we change just the parameter count to 3. Okay, we check if all is fine. Yeah, from the logs, yes. And finally we get the link, we paste the secret ID, and all should be work. So now we check the link, and yeah, we have the Nginx app deployed without doing nothing, just using the natural language. So we can continue here. Okay. Okay, in this slides I have also included the GitHub link to the project if you'd like to explore it more further. Currently, the server supports various functionality, including listing node, checking job status, viewing allocation, creating and deleting variables, policies, and interacting with just house volume actually. But in the future, I plan to add more features like plugin support, monitoring hooks, and multi-agent coordination. I've also started working on a console MCP server, which is still a work in progress. You can also find it pinned on my GitHub profile along with the roadmap of the planned feature. Thank you for the attention. If you're interested, the code is available on GitHub, and feel free to reach it via email or Telegram if you like to discuss the project, propose collaboration, or just share ideas. It's been a real pleasure to present this work to you. Thank again for the opportunity, and I hope more like this will follow. Thank you. Bye.